Okay, so in this video, we're going to try something new. I'm going to try and use my iPad to film this instead of doing it on paper. So hopefully this works. In this video, we're going to be looking at this section here. Today, as you watch a couple videos, maybe you will look at this section here, and then, no spoilers, we'll look at this section here. So that'll be what you're responsible for today. But let's get into this first idea, which is how to find intercepts, x and y intercepts. The first statement here says that a function can have at most one y intercept. And this is of course true. A function can have at most one y-intercept, and it says to think of the vertical line test, and if you thought about it for a second, you'd realize if a function has two y-intercepts, then it has to cross through both of them, maybe looking something like this, in which case this would definitely fail the vertical line test, crossing through more than one. So it's actually impossible for a function to have more than one y-intercept. But also notice, a function can have as many x-intercepts as it wants. And I've been using that word, but remember, intercept is where it crosses the x or y-axis. Okay? So it can have as many x-intercepts as it wants, but it can only have one y-intercept. So let's find a couple. So what are the x-intercepts of this graph? Well, it seems pretty clear that we have an x-intercept here, here, and here. So maybe we write those first. Where are my x-intercepts? And an important note, x-intercepts are points. So they are coordinate points, so they have x comma y. So what's this point right here? This is the point -3, 0. I would know what you meant if you wrote x equals -3, but that's not an x-intercept. An x-intercept is a point, so -3 comma 0. This point, +2, 0. And finally this point way out here, +6, 0. Okay. What about this intercept? This is a y-intercept, of course. So what's that y-intercept? Just like earlier, that's a point. It definitely crosses the y-axis at 3, but what's the point? The point is 0, 3. Okay, and these would be our x and y intercepts here. Not too bad. What's a little bit more challenging is the instance where you're asked to find the x and y intercepts from an equation. So there's a couple rules here. If you're trying to find y-intercepts, it's very easy. You're going to plug, writing. You're going to plug, there we go, in a 0 for x. So let's do that right now. If this is f of x, or a lot of times we'll write that as y equals 3x plus 7, if I'm trying to find the y-intercept, I'm going to plug in a 0 for every x. In this case, there's only one x. So we have 3 times x plus 7, or in this case 3 times 0 plus 7. So that's going to be 3 times 0, or 0, plus 7. That's just 7. Okay? But remember, the y-intercept is a point, so we would write it as a coordinate point of 0, 7. This graph right here, if I was to draw it, would cross the y-axis at a height of 7. Okay? And it probably ends up looking like this, but that's not the point. The point is, can you find where it crossed the y-axis? And we did. It's right here at the point 0, 7. Cool. That's how you find y-intercepts. How do you find x-intercepts? So let's go back. Woo. Sorry, I'm going to have to find a better way to delete a bunch of stuff, but that's where we got. Okay, so how do you find x-intercepts? What is happening? What is happening? Go away. Okay. Oh, the joys of technology. Okay. How do you find x-intercepts? To find x-intercepts, you set y equal to 0 and solve. Okay, so remember, to find y-intercepts, you plug in a 0 for x. So then to find x-intercepts, you're going to plug in a 0 for y. So remember, this we called y. So we're going to plug in a 0 for y, or set y equal to 0, or set the function itself equal to 0, and now solve for x using some algebra. Maybe the first thing I do is subtract 7 from both sides. I get negative 7 equals 3x. And then maybe the next thing I do is divide by 3. And I get, as a final result, negative 7 over 3 equals x. Negative 7 over 3 equals x. But again, if you box this answer, yeah, I'll know what you mean, but x-intercepts are points in space. So if it crosses the x-axis at negative 7 over 3, which is just some negative number, what is this as a coordinate point? And it's the point negative 7 thirds comma 0 is where this would cross the x-axis. Negative 7 over 3 comma 0. All right, great. So then let's move on now to this stuff. Excuse me. So we're going to be looking at domain, range, all the way down to constant intervals, and talk about how we write this. So just reading here, some common information is going to be us when we're writing interval notation for the following. We're going to use the x-axis as a referent and always go from left to right. So that's actually very important. Anytime you see the word interval, which is all of these, right? Anytime you see the word interval, you should remember that we are referring to a section of the x-axis, and we're always reading left to right. Okay, so let's. I'll read these real quick. Domain are the x values, so a lot of times we think of how far left and right does the graph go. The range of a function are the y values, so a lot of times we think of how far up and down does it go. Domain, we would read left to right. Range, we would read bottom to top. Okay. Continuous. A function is continuous if you can draw it without picking up your pencil. So this would be an example of a continuous function, right? A function is discontinuous if when you draw it, you have to pick up your pencil and then continue on. This here, this gap, is a discontinuity. And we'll see examples of all of this here in a second. And then increasing, decreasing, and constant. A function is increasing if it's rising from left to right. This would be an example of an increasing function. A function is decreasing if it's falling from left to right. This would be an example of a function that's decreasing. And a constant function is just a flat line. This would be constant. Okay? So this is what we mean when we say these things. But how do we specifically identify intervals where this is happening? So let's look at a few concrete examples, and then we'll end the video and start our next video. Well, I guess I don't have to delete that stuff. Okay. In this first example, I've given you a random graph, and we're going to try and find all this information. So the first thing I'm going to do is find the domain of this function. Remember, your domain is your x values. So maybe we use I don't know, blue. So the domain is from left to right, how basically wide is the function. So from left to right, it looks like the furthest left that this function goes is here at -5. And it's continuous until it gets to here at 7. Okay? So the domain is all numbers in between -5 and +7. There are no breaks in the graph, so it's perfectly clean from -5 up to 7. So great. So then how would we write that as an interval? Well, it goes from -5 to 7. From negative 5 to 7. How are we going to cap this off? I hope you agree that the negative 5 is going to get a bracket because it's included there. That's a closed circle. But the 7 is going to get a parentheses because of this open circle. So that's the domain of this function. Cool. What about the range? What's the range of this function? Well, range, if domain is left to right, then range is bottom to top. So what's the lowest point we have here? And it looks like it's way down here at negative 2. And then what's the tallest point? Well, it goes up and up and up and up and up until it goes to 4, and it never gets higher than that. So it looks like the range would be all the numbers in between negative 2 and 4. So from the low point of negative 2 up to a high point of 4, and then how are we going to cap this off? Well, that low point is a closed circle, that high point is a closed circle, so they're both going to get some brackets, okay? They're both going to get some brackets. Awesome. No. Sorry, I'm learning this tool, so I'll get better, I hope. Okay. Some a little bit tougher now. First, let's remember what these are asking. Where is the function increasing? So visually, it's increasing. If we'll zoom in a little bit, it's increasing for all of this stuff. All of this stuff is where it's rising. As you read left to right, we are going up over that section, and as we read left to right, we're going up over this section. So it's pretty easy to identify that this section is increasing and this section is increasing. Okay, I don't think that would be too difficult to see. It's also pretty easy to see where it's decreasing. It's clearly falling left to right over this section and falling left to right over this section. So these two sections here and here are decreasing. Okay? So we're at least able, I think, to identify where they are, but now the question is how do we write out those values? The last thing I'm going to say is notice there is no constant interval, at least in this graph. There's no space where it's perfectly flat. It's either rising or it's falling. In this specific example, there isn't a section that's flat. Okay, so let's look at the increasing spaces. Well, we've already said that it's increasing over this section here and over this section here. But these are intervals, and so we've already alluded to this. These are sections of the x-axis. So we're actually referring to the x-axis here when I say, yes, all of this is increasing, but over what section of the x-axis is that happening on? And it's happening over this section. From negative 3 to an x value of 0, the function is increasing. Okay? So it's increasing from negative 3 to 0. Negative 3 to 0 on the x-axis. What we don't want to say is it's increasing from, I'm going to write it in red because this is wrong. A lot of people want to say, oh, isn't it increasing from 1 to 4? And yeah, but those are y values. That's up and down. We want x values, okay? So that's why I've highlighted the x-axis from negative 3 to 0, because that's how we're going to write these intervals. Cool. And the cool part about increasing intervals is that, well, so a couple things. Thing number one is it goes from negative 3 to 0. And there's actually another interval here. But when we're writing increasing intervals, we always get to use parentheses. We don't ever have to worry about brackets when we talk about increasing and decreasing intervals or constant intervals. Those are always parentheses every time. There's another section where it's increasing. This one's kind of actually a little bit tougher. Notice it starts increasing here and stops increasing here. So we're looking at this section of the graph. But what x values is that? It starts increasing when x is 4, and it stays increasing until when x is 7. So also from 4 to 7, we have this. So there's actually two intervals of increasing. This interval it's increasing, and this interval it's increasing. Okay? Hopefully you see why the 4 is included, because it starts the increasing process at 4 and continues to increase until you get to 7. Okay, great. Undo some stuff here. No. Oh, sorry, 4 to 7. And we're going to include the big U in between these two sets because, dang it, we're going to include the big U in between these two sets because that's the symbol that joins the two sets. If I want to talk about negative 3 to 0 and 4 to 7, those are together as one set, so I put that U. All right, where is it decreasing? Visually, it's decreasing here and here. We've already talked about this, but what section of the x-axis is that happening on? It looks like it's decreasing from negative 5 to positive 3, and it's decreasing from 0 to 4. When x is negative 5, it starts the decreasing process and stops at negative 3. And when x is 0, from 0 to 4, it's decreasing. Okay. So my two decreasing intervals are from negative 5 to negative 3, always parentheses. And, so there's another part, and from 0 to 4. Cool. And that's the full picture of things. This is where it's increasing and decreasing and constant, and those are its domain and range. The last thing I want to say is that this is a continuous function. It is continuous. If I were to start drawing this, I would never have to pick up my pencil to draw it. The only question would be, what's this closed circle? And that's not going to affect whether or not it's continuous, if that closed circle is at the end. If the closed circle was in the middle of the graph, or I keep saying closed, this open circle is not going to affect whether or not it's continuous. Sorry, the open circle doesn't affect that. If the open circle was in the middle of the graph, then I would have to pick up my pencil before I could continue on. So this would be discontinuous. But if that open circle is at the end point, then it's still continuous. Okay. Last example, and then we'll end the video. What's the domain and range of this function? Let's do domain. So remember, your domain is your x values. And do you see how this function just goes down forever? So if we're reading left to right, it's forever. It's going to go forever to the left. It's going to keep going that way forever. So when we think about our domain, it's from negative infinity to, okay, what's happening here? Does it stop at negative 2? And negative 2 as an x value is included in the domain. So that's good. And it keeps going until positive 2, right? So even though there's a break in the graph from negative infinity to, we had to check negative 2 because it looked kind of weird, but that was still good. Negative 2 actually goes somewhere, so negative 2 is in the domain, up to positive 2. So from negative infinity to 2, that's part of our domain. But then there's this whole section here that has nothing going on, right? For example, 4 is not in the domain because the x value of 4 doesn't ever touch the graph. So that's not in the domain. So it actually stops, the domain stops at 2 and doesn't pick back up until here at 6. And from 6 to infinity, we pick stuff back up. So there's kind of this middle break where there are no x values that are on the graph. So the domain here is from negative infinity to 2 and from 6 to infinity. From negative infinity to 2 and from 6 to infinity. So let's write that. From negative infinity to 2 and 6 to infinity. If you wrote from negative infinity to negative 2, from negative 2 to 2, and from 6 to infinity, I would also accept that. Okay, what about the range? Remember, range is low to high, so what's the lowest point on this graph? And notice it just goes down forever in both directions, actually. So because of that, the range would start way down here at negative infinity and keeps going up and up and up until the highest point, which is 4. Okay. This graph has a low point of negative infinity and a high point of positive 4, which is included. Okay. Awesome. Let's look at our increasing, decreasing, and constant intervals. So I'm going to go pretty fast through this. We'll start first with our increasing intervals. It's increasing over this piece, but that's not how we write it. Remember, we write it as an interval, so it starts increasing at negative infinity and continues to increase, going up, 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 until I get to negative 2. Okay? So it's increasing from negative infinity to negative 2. What's this middle section? Notice it's constant in this section. That's nice. But how do we write it? Remember, always staying on the x-axis. So it's constant from negative 2 to 2. And with these, we always use parentheses. We don't have to worry about any brackets. And then clearly, notice nothing's going on between 2 and 6, so we don't have to worry about that. But once x is 6 and beyond, the function is decreasing. So from an x value of 6 often to infinity, the function is decreasing over that section of the x-axis.